All right, everyone, here we go. Some problems to do with power. Let's start with a really simple one first, with that first equation we learned. Power is work over time. Let's lift a box up to a high shelf. So let's say we've got a bookcase or something, a box on the ground, and we want to lift it up to go on top. The work here is going to be the change in potential energy, so it's going from 0 down here to a lot more, mgh up here on top. We'll have to make up some reasonable numbers here, so let's say the height of a bookcase is about 2.5 meters. Let's say the mass of our thing is, I don't know, 12 kilograms. That seems fairly reasonable. So that its PE at the top is going to be, I'll plug this into a calculator real quick, 12, 2.5, 9.81. So it's going to be 294.3 joules up there. So that's the work done. We added that much energy to the box by lifting it up. And then we're going to have to figure out the time it takes to do that. We can just make up a number. How long would it take me to lift a box up? I don't know, 3 seconds. So it's going to be this work, 294.3 over this time, 3 seconds. 294.3 over 3 is equal to, plugging in again, 98.1 watts. And that's pretty nice. That's 9.81 times 10. There is a reason for that. Actually, if you look at this, there's a fairly meaningless, trivial mathematical reason why it's 10 times 9.81. Hey, extra credit. Go figure out why. Exercise left to the reader. Okay, so that's pretty nice. Let's also convert that to horsepower. Let's see. In my lecture, I think I said that 1 horsepower is... Oh, I said in my lecture 746, didn't I? It's actually 745.7 watts. That was a typo in my notes, I think. I got confused when I was looking it up in my notes because I think I said 746 and also 745.7. I think I was rounding it up at one point. This is the real number, 745.7. Don't use that 746.7, although it's close enough that it's not going to make a huge difference. Okay. So we're going to want to take our 98.1 watts, and we're going to want to divide by this 745.7 watts per horsepower. There are more horsepower is a bigger unit, so there are fewer of them, so we should be dividing this. So we're going to get 98.1, why can't I do 98.1, over 745.7 is equal to, hold on, I get 0.132 horsepower, which is not very much at all. Which is actually pretty reasonable for a human being. Human beings, in most circumstances, should not be in large fractions of a horsepower. Okay. How about we use that other equation? Power is force applied times velocity. For one, let's say we move a box across some distance. I'm going to have to make up some numbers. Force of 40 newtons and velocity 2 meters per second. That sounds reasonable. This isn't so bad. 40 times 2, I don't even need a calculator for that, is 80 watts of power. Okay, how about we do something a bit more interesting? I have in front of me here, let me switch over to my camera. I have in front of me here ice cream that I've been working on for the last 3 hours while I've been making this video. So it says on the back of the carton, it's 280 calories per serving, which is, there are 3 servings, so 840 kcal in this container. That's like a third of what I should be eating in a day. So that's a whole meal right there. Good for me. Good for me. I'm doing well. Quarantine mood, you know. So let's say I've eaten it over 3 hours. Let's find out my power input, not really output, right? It's my intake. Let's convert 840 kilocalories into joules. So we're going to want to take that 840 times 4184 joules per kilocalorie to get the number of joules in this thing. It's 3,514,560 joules. Good Lord. That makes me feel even worse about eating an entire pint of ice cream. And if I took 3 hours in seconds, it's going to be 3 hours times 60 minutes times 60 seconds is 10,800 seconds. Okay. So really all I need to do is the energy intake divided by the time. So the power is going to be 3,514,560 over 10,800. So I get my power intake is 325 watts, which if we look at the homework, I'm asking you to work with light bulbs. So in this room I have, let me count, 1, 2, 3, 4, 5 light bulbs going on right now. If they're all 60 watt light bulbs, oh yeah, that's about 60 times 5 light bulbs is about, yeah, it's 300. So my power intake in the last 3 hours has been about the same as the output of my 5 light bulbs in 1 hour. No, it's just my power intake has been about the same as my 3 light bulbs, 5 light bulbs. That's kind of disturbing. Okay. Hey, and then talking about the homework too, I'm going to start a new little document here. Talking about the homework, I want to clarify a bit about what it means. What I'm asking you to do is count up the number of light bulbs in your house and then do some calculations. So maybe you have, I don't know, there's 5 light bulbs in my room that I can see right now. Oh no, there's 6. There's one that's off. Let's say 6. And then what I'm going to ask you to do is, say there's 6 light bulbs total. You'll have 3 categories. 1, 2, 3 categories. The first one is going to be regular 60 watt light bulbs. The next one, and I can't remember what the number is exactly. I think it's about half. I think it's about 30 watt. So these 60 watts are incandescents, which I don't even think you can buy anymore. Then 30 watts are fluorescent, compact fluorescent light bulbs, the little spirally ones. And then third category is LEDs, which is what I have at home, which are, I think, about 15 watts. I'm going to have to look that up for the actual homework. So I would want you to calculate the total wattage of all your light bulbs in your house. Go around and count them if you had these 3 different types of light bulbs. So here, 60 times 6. 60 times 6 is 360. I should have known that. 360 watts. 60 times 30 is 180. I should have known that because it's just half. And then it's half of this, so 90. Ha! So at least I can do some math in my head. So these are the wattages of all the light bulbs in this room that I'm using right now. There could be a lot more in my house. And what I'm going to give you in the homework is a price that P&M charges. It'll be dollars per kilowatt hour is what they list, right? So kilowatt hour is an interesting unit. It's actually a unit of energy used. It's not power, even though it uses watts. It's really power times time. If you remember that power equation. Power is work over time. If you multiply that by time, well, hey, the times are going to cancel out. It's just going to get you energy or work done here. But most energy utilities, I mean, every single one that I've seen at least, list their energy rates in terms of dollars or whatever the currency is per kilowatt hour, which means this is a really weird unit, kilowatt hours. It's like, you can think of a kilowatt, 1,000 watts, used in 1 hour, which is like a standard amount of energy. Let's figure out how much energy that is actually. Let's see. Actually, I looked this up earlier. It's in my notes here. Let me find it. So 1 kilowatt hour, I looked it up, there it is, 3.6 times 10 to the 6 joules. That's 3.6 million. Huh. And if you remember, the energy in my ice cream pint was 3,500,000 something thousand, which is almost exactly this. So it's about a kilowatt hour in an ice cream pint, which is hilarious to me. That is great. An ice cream pound is about a kilowatt hour of energy. I never knew that before. So I'm going to give you this price that PNM actually charges us here in New Mexico, price per kilowatt hour. You'll have to convert these 360 watts, 180 watts, 90 watts to joules per second. Well, I mean, it already is joules per second. It's not really a conversion I want you to do, actually. Really, it's I want you to make some assumption about how long your lights are on in your house. So maybe you say during a normal day, not during quarantine, you're not home for, most of the day from, say, 7:30 to 5 o'clock or something like that. So, and maybe you don't have your lights on the whole time. So maybe you have your lights on for, 6 hours while you're awake and at home. So that'd be 6 hours per day. What you'd want to do is you'd want to take this 6 hours per day, multiply times your wattages here. So if the watt is really joules per second, let's say 90 watts equals 90 joules per second. What you're going to want to do is you're going to do 6 hours per day. You're going to want to convert this into to seconds again. So I guess really instead of 6 hours, you're going to want to do 6 hours times 60 minutes times 60 seconds is 21,600 seconds. So really you're going to do 90 joules per second times that 21,600 seconds. That's 6 hours equals 6 hours. The seconds are going to cancel out. You'll get 90 times that. I just did it here really quick. 1,944,000 joules of energy used by my 6 light bulbs in 6 hours. Okay. Then you're going to want to convert this amount of joules into kilowatt hours, kWh, right, with this conversion, 1 kilowatt hour being this many. So just divide by 3,600,000. I'll do that now. 3,600,000. Woo, my calculator did some weird things. Nice. Yours might too. Make sure to put parentheses around your denominators, everyone. It's a big problem. Okay, there we go. And the energy for my 6 LED light bulbs here, remember it was 90 watts for 6 of them. I converted into joules. Now I'm converting into kilowatt hours. I had 0.54 kilowatt hours for my 6 light bulbs in a day, right? I could do this, I could say this is one day, maybe I want to do it for a whole year. Times 365. 1 year would be 197.1 kilowatt hours in a year for me to run these 6 light bulbs for 6 hours a day. Then what you'll do is you'll just multiply by the cost per kilowatt hour, which is going to be given on the homework. I have to look it up again. It's actually pretty small. We're talking about cents. So I want to figure out the total cost to run these light bulbs for a year. And the whole point of the homework is to compare the LEDs, the CFLs and the incandescents, and just to see how much more cost-effective these LEDs are, even though they are more expensive to buy. All right, I'm sure that was not a sufficient explanation, but I hope it's enough to get you started, and when you have more questions, go ahead and email me. All right, thanks. Have a great week.